This video is going to show you a quick way to apply all your exponent rules using PEMDAS. You've learned in an earlier course that PEMDAS is the order of operations. Parentheses, exponents, multiplication and division are next to each other because they have the same strength. You do them in order from left to right. Same with addition and subtraction. PEMDAS can be used to learn all of your exponent rules. So let's illustrate with this example right here. 4h to the 7th times negative 3h squared. Well, first of all, 4 times negative 3, those are regular numbers. Those are not exponents, so they've always been negative 12. It will continue to be that. But then when I go to the variables, I have an h to the 7th times h to the 2nd. Notice I said times because this is all held by multiplication. So here's what I do. Since the bases are the same, I keep the base of h, and then for the exponent, I apply the operation listed below the given one. So what was given? Multiplication. What's below? Addition. So I add 7 plus 2 to get 9. So this is negative 12h to the 9th. The next one, I have x to the 5th raised to the 3rd. So that's an exponent to another exponent. That's right here. So since I have like bases, first I keep the base, and then, since I'm at exponent, I drop 1. I'm going to multiply my base 5 times 3 to get 15. Next, I have like bases, p and p, held together by division. So what am I going to end up doing to the exponents? One below, I'm going to subtract. And the order I subtract is the top minus the bottom, so 7 minus 5 would be p to the 2nd. Now, just in case you get one where the exponent is larger on the bottom, if you go and think about it this way, because all of our answers need to be positive, you can still subtract, okay? But because the bigger exponent is down in the bottom, the p to the 2nd will be down in the bottom, so it would be 1 over p to the 2nd. And I explained that another way in our video where we work them out the long way. Okay, this one looks complicated, but it's really not that bad. We're going to handle this part first with the outer exponent of 2. So I spot 2 different bases on the inside, so this 2 needs to be distributed to both. Right now, that's a b to the 1st. Might be helpful if you write that in. So I'm going to distribute, and when I distribute, again, that's exponent to an exponent. It means I multiply. So I'm going to do y, keep my base to the 5 times 2 is 10, b to the 1 times 2 is 2. And then I will just recopy the y to the 3rd, b to the 7th. So I do it in 2 steps. Now I look for my like bases. When I do this, I always go alphabetical order. It's best practice. Not wrong if you do it the other way, but best if you do the b's first. Now these are held by multiplication. So what am I going to do? I'm going to add the exponents. So that will be b to the 9th. Then I go to the y's. So I have a y to the 10th times y to the 3rd will be y to the 13th. I now have a quotient. So I begin with coefficients. These are normal numbers. These are not like bases, so don't apply exponent rules. You're just going to reduce negative 28 over 20. 4 goes into both, be negative 7/5. If you can't do that in your head, use your calculator to reduce your fraction. Then, this is held by division. I keep my base on the top. That's where the greater exponent is. And I take my top exponent minus the bottom one. So 4 minus 1 is 3. There's no like bases, so I'm finished. Okay, this one, try it on your own. Tell me what you get. Hit play when you're ready. I first get b cubed times b to the 15th, which then becomes b to the 18th. The reason I have this last one is because of this negative 5. There's 1, 2, 3 different bases on the inside, and I have an outer exponent of 2 that needs to be distributed to all 3. But here's what's important. This negative 5 is in parentheses. So it is negative 5 that is being raised to the 2nd power. Then I'm at exponent to an exponent. That means I'm going to multiply them together. So d to the 14th, g to the 6th. Lastly, I know that negative 5 to the 2nd is negative 5 times negative 5, or 25, d to the 14th, g to the 6th.